2 and 3 from your textbook. So right now we're on page 182 from your textbook, okay? Page 182 in your text. This question, they've given us a parabola, and they've also given us 2 coordinates. The top coordinate, what is this called? Anyone know? A vertex. Vertex is at 1 and 5. What about this point here? Y-intercept. Good. So this is our vertex. This is our y-intercept. And that coordinate is at 0 and 2. So they've given us 2 coordinates, and they would like us, they said, to determine the equation. In other words, they want us to figure out an equation that looks like this, or y equals a, bracket x minus h, bracket squared, plus k. But they want us to have numbers for a, h, and k. So, first off, I look at my vertex. My vertex can give me the values of h and k just by looking at their numbers. First of all, k is going to be in reference to our y-coordinate of the vertex. And since y is positive 5, what is k going to be? Positive 5. So we already know we can replace k with positive 5 because that's the y value of our vertex. And just draw in the other parts here. Y equals squared. Okay. Next thing we're going to deal with is our h. We need to figure out what h is. Now, our h has the value, or is on the vertex, refers to our x value. And our h is technically positive 1 right now. But when we are doing h, we always got to think opposite. So what number would I put inside those brackets? Negative 1. That's right. Okay? So I'm going to put in negative 1. Even though our x value is technically positive 1, we're going to put in negative 1 for h because h is backwards. So I already have 2 of the points. Now looking at this, I don't quite know what this point is, these other points here. So I'm not sure if this is a normal parabola, a stretch parabola. I have to still figure out what my value of a is. Luckily though, they've given us our y-intercept. Our y-intercept is just a value on our parabola for x and y. So I can actually replace x in this equation with 0 and y in this equation with 2 in order to solve for my a. So, my very next step, I'm going to replace the y and the x in this equation. Okay, so it was pointed out to me, this is a good way, what we'll do is we're going to check it. You guys have noticed that the movement from our vertex to our y-intercept is 1. And we know that we're going down 3 spaces. And normally we go down 1 spaces. So you guys have already figured out that our a should be equal to negative 3. We're going to prove that, okay? So we'll write it in red here so it stays. We think a, or we, from looking at this, know that a should be equal to negative 3. We need to prove it with our numbers. So we're going to do this through solving numbers, because not every time will a be a nice round number that's easy to look at. So we are replacing our y value with our y-intercept 2. So we know 2 is equal to, I'm just going to write a in black, x, whoops, sorry. And we're replacing our x value with 0, right? Here's our x value, so x is now 0. Subtract 1 squared plus 5. Now we just have to follow BEDMAS and solve for our a. 2 is equal to a negative 1 squared plus 5. 2 equals a. This becomes positive 1. So really it's just 1a. I'll write it here anyways. Plus 5. 2 equals 1 times a is a plus 5. And finally, I'm going to move my positive 5 to the other side to solve for a. So it becomes 2 subtract 5 equals a. What does a equal? Negative 3. Just like you guys said. So we proved it through our numbers by subbing in what are the points we have on the parabola. We know that a is negative 3. I'm not finished though. My final equation is y is equal to negative 3, that's our A, x, subtract 1 squared plus 5. We replaced all of our values. Our A is negative 3, our H we replaced with negative 1, and our K we replaced with positive 5. That would be our final equation. You have to put it together into a final equation. Okay, let's move on to question number 3 on text page 183. Question says that a firework display, a firework is launched from the height of 2 meters above the ground and reaches a maximum height of 40 meters at a horizontal distance of 10 meters. Okay? First they want us to determine the equation of the model and the flight path of the firework. Okay? So, first off, they told us that when it starts, and when any firework or anything is running, we're shooting something, we're starting at x is 0. Okay? So when the firework starts, it's 2 meters above the ground. So our y is our height in meters, and this is our distance in meters. Okay? X is distance in meters, y is height in meters. Because we start at 2 meters above the ground, we're not at the origin right now. Our y-intercept looks like it's 0 and 2. They also told us that the highest point is 40 meters in the air, and at that point it's 10 meters away in distance. So they're talking about our vertex is at 10 and 40. So we know our firework does something like this. Comes back down. We don't know where it crosses our x-axis there. Okay? So we've drawn the flight path of this firework. Now what we're going to do is the exact same idea we did before. We're going to try to find the equation of this parabola. So we know that y is equal to x minus squared plus a, h, and k. Okay? We have these values. According to our vertex, this is our k value right here. The y value of our vertex is 40, so I can replace k with the number 40. So we know k is positive 40. I'm just going to write out the rest of the spots so that we have something to fill out. Okay. Next thing we're going to do, this was our k value, or the y. We know our h value deals with the x value of our vertex. Now, once again, because x is positive 10, what do I replace h with? Negative 10. So I put negative 10 in there. Okay? And finally, we don't know what this is stretched by. For instance, this goes over 10 and down 38. I really can't figure out a by looking at that. Normally, if I go over 10, should be going down 100. So the difference between 38 and 100, I actually know what it is, but I'm not going to tell you. We're going to try to figure it out. Okay? So our A, we have to solve for A. We do have another coordinate right here, and it gives us an x and a y value. So we're going to replace our x and our y with this coordinate. So when we go to write it in, I'm going to do it all in black now. My y is 2. I'm trying to solve for A. My x is 0. Is that the exact same from above? Oh my gosh, exact same one. Same coordinate. 0. Minus 10 squared plus 40. We need to figure out what A is, so I'm going to quickly carry out the math here. Negative 10 squared plus 40. 2 equals 100A plus 40. This becomes 100A is equal to negative 38. A equals negative 38 over 100. So this is one of those instances where A is in a very nice round number. In fact, it's a fraction. I could write it as a decimal also. Decimal would be 0.38. Okay? So look at that. A is not a nice round number, but I could still make an equation out of it. My final equation is going to be y is equal to, I can write this as a fraction or a decimal, negative 0.38 x, subtract 10 squared plus 40. And in this instance, I have my k value, my h value, and my a value. Okay? So we've got our equation, which is imperative for solving B. B says after the vertex, let's say it's moved another meter to the right. So in other words, from our vertex, we've gone a meter to the right. So where's the point? We know it's somewhere there. What's our y value going to be? We already know the x value because it's going to the right one is going to be what? 11. So the next point x value is going to be 11. So we'll just kind of do that in red. We know our x value is going to be 11. We're trying to find out what our y value is going to be. Well, I already have an equation, so I can plug in an x value to this equation and solve for my y. So I take my equation, y is equal to 38, plug in my x value, 11 minus 10 squared plus 40. And I just got to solve for y. That's going to give me my next value. 1 squared plus 40. 1 squared is 1 times that. Negative 0.38 plus 40 gives us 39.62. There we go. So our y value is 39.62. I just carry out the rest of the math. Once I have an equation, I can plug values in to find x and y coordinates.